Hello everyone, welcome to Unit 3, Lesson 5. This lesson we're going to now look at another exponent law that relates radicals to exponents, and it's called the Rational Exponent Law. So what you probably saw while you were reading your notes is that we could now have fractional exponents, and fractional exponents can also be written in radical form. It's going to be to your advantage to be able to switch back and forth from one form to another. It allows you to be able to punch things on your calculator quite easily, either in either form, in exponential or radical form. I tend to actually punch most of my calculations in my calculator in exponential form. I always find that the graphing calculator is a little bit clunky when it comes to using the radical form. And you'll see that. I'll show you an example of how I do that. So I'm going to go through about 8 different examples of either simplifying or evaluating either in radical or exponential form. We're going to start off kind of simple here. Our first example is going to be just taking the number 64, example number 1. We're going to write 64 to the power 1/2. Now you can actually punch this on your calculator as you see it. The only thing that you have to do is you actually have to use your little hat sign, and I'll write this on the slide here for you, how you'd be able to use the calculator. All you would do is punch in 6, 4. You would use your little hat symbol, which is just under your clear sign, and then in brackets you would go 1 divided by 2. And your calculator can evaluate this for you. 64 to the 1/2 will be 8. The other way you can look at this is anytime you see a denominator, the denominator is telling you what root you need to take. So this is going to be the square root of 64 because the denominator is 2. And we already know that we don't show an index of 2. So the square root of 64 is 8. So however you want to do this, if you could do it with your calculator, the only thing that you have to remember when you're doing this with the calculator is you have to bracket the exponent. As soon as there's more than one number in the exponent, you always have to bracket it on your calculator. If you forget the brackets, you don't get 8 as an answer. You actually get 128. Alright, so you have to remember that you use that little hat symbol that basically means raised to the power, and then we put in whatever power in brackets, and you'll always get that right answer on your calculator. Example number 2, pick something a little bit more challenging. We're going to write this as -8 to the power 2/3. There's actually a couple ways to write this. Again, if you wanted to go with this on your calculator, you would have to put the -8 in brackets and then use your hat symbol and then go 2 divided by 3, and you will get on your calculator 4 as an answer. The way it could look if you change it to radical form, we're going to -8 squared, and we're going to take the cube root of it. Now the neat thing with changing this to radical form is it doesn't matter whether you take the cube root first and then square it, or to square first and then take the cube root after. It really doesn't matter as long as you know you don't mix up numerator and denominator. The numerator always stays with the base. The denominator is your index of your radical. While the cube root of 8 is -2 squared would be equal to 4. So you need to be able to switch from one form to another in terms of being able to evaluate as a radical or being able to evaluate as an exponent. In the next lesson, we're going to solve both radical and exponential equations, so you need to know both methods. Example 3, we'll go a little bit harder. we're going to simplify 16 over 25 to the power negative 3/2. Well, the first thing I would do is use my negative exponent law, and I would write this as 25 over 16 reciprocal. Then you could change the sign on the exponent and write this as positive 3/2. Again, if you want to punch it in on your calculator, you can, but I can actually separate this out as being 25 cubed, take the square root, over 16 cubed, take the square root. Take the root, raise to the power 3. And again, it doesn't matter what order you do. You could take the square root of 25 is 5 cubed. So this would be equal to 5 cubed over 4 cubed, which will equal to 125 over 64. Which you would have got that same answer had you punched it on your calculator and then changed your answer to a fraction. Example 4. We have, now we'll work with some variables. This one now you can't use the calculator once you start to see the letters. A squared, b cubed, c to the 4th. And we're going to raise this whole thing to the power 1/3. Well, this is power of a power. All we're doing now is just multiplying fractions. So it'll be 2 times 1/3 to give you a to the 2/3. 3 times 1/3 will give you b. C to the 4th times 1/3 will give you c to the 4/3. There's no like terms, so we can't simplify this any further. So when you're evaluating, you could punch it in directly onto your calculator. When you're working with the variables, you have to apply the exponent laws. Power of a power means multiply, which now you're going to multiply fractions. If you saw multiplying powers, you'd end up adding the fractions. Example number 5. We have, starting with a radical form. So we're going to take the cube root of 729. And then we're going to take the square root of the answer. Now if you want to change this to exponential form, this is how it looks. You'll have 729 was the base. And since we're taking the cube root of it, it's really to the power 1/3. And then again, since we're taking the square root of it after, so we'll put brackets around it, then take the square root, which is to the power 1/2. So if you wanted to simplify this, this is really 729 to the power 1/6, or the 6th root of 729. If you want to punch this in your calculator, again, what I would probably do, since this is just an evaluation, 729, hat symbol, and in brackets, 1 divided by 6 will give you the answer of 3. You could do this in a couple steps as well. We've already worked with cube roots, so take the cube root of 729, then take the square root of that answer. Well, the cube root of 729 is 9, the square root of 9 is 3. Works either way, as long as you just remember that you take cube root of the original number, square root of the answer. Example number 6. We'll work with some variables again. We're going to look at x to the cube, 5th root of x cubed, times cube root of x squared. I always find it easier to convert these to exponential form, then simplify, than to work with the radical form. So what I would do with this is write that first term as x to the 3/5. The second term becomes x to the 2/3. Now remember, this isn't power of a power, so what we need to do, since it's multiplying powers, we're going to add exponents. So it'll be 3/5 plus 2/3. Well, when you add exponents, you need to have a common denominator. So we're going to have 15 as the common denominator. So 3/5 will be 9/15. 2/3 will be 10/15. So our final answer here is x to the power 19 over 15. With rational exponents, you will see fractions in exponential form. For example 7, we're going to start to look at simplifying a few terms now. Example number 7 is 8 to the negative 1/3 times a squared to the power negative 2/5 times b to the negative 1/5. We're going to divide this whole thing by 2 ab to the power negative 1/5. Well, the first thing we should do is go do power of a power. So we can write this as 8 to the negative 1/3. A will be to the negative 2 times 2/5, gives you a to the negative 4/5. B to the negative 1/5. On the bottom, we get 2 a to the negative 1/5, b to the negative 1/5. Well, just like in the last lesson, I was always making negative exponents positive, so that's what I'm going to do now. I'll move that 8 to the 1/3 down, a, b down, and the 2 in the bottom to the top. So it'll be a to the 1/5, b to the 1/5, over 2 times 8 to the 1/3, a to the 4/5, b to the 1/5. Now we can simplify. Nothing to simplify on the top. On the bottom, I can simplify the two coefficients. The cube root of 8 is 2 times 2 will give me 4. Notice I also have a b to the 1/5 and a b to the 1/5, so I can divide those out. So it's going to leave me here with a to the 1/5 over 4 times a to the 4/5. And one more step will now mean that we'll have to subtract exponents. So 1/5 minus 4/5. This answer could be written as 1/4 a. And I'll just show you the in-between step. 1/5 minus 4/5. So our final answer can be written as 1/4 a to the negative 3/5. Or, if you wanted to write it a different way, you could write this as 1 over 4 a cubed to the 5th root in radical form, one way or another. Reciprocal, so move it to the denominator to make the exponent positive, then change to radical form. Won't matter which answer you're looking for. I guess it just depends on which choice you're given on the exam. So same rules apply. The only thing that we're going to see with radicals is now that we're going to have fractional exponents. The denominator of the fraction is your index of the radical. The numerator is what you're going to raise it to. And you just keep simplifying using your exponent laws. One last example. Example number 8. We have x to the 5th y cubed. We're going to take the 4th root of it, and then we're going to raise the whole thing to the power 3/2. Again, the first thing I would do is change to exponential form. So this would really be written as x to the 5/4, y to the 3/4, and it's raised to the power 3/2. So now we have power of a power, which means multiply. So it's going to become x to the 5/4 times 3/2, which gives us 15/8. Y to the 3/4 times 3/2 will give us 9/8. Nothing left to simplify. X and y are not like terms. So what I also want you guys to work on, practice simplifying and evaluating radicals. Practice working on exponent laws with rational exponents. Remember that you are just multiplying and adding fractions, just like in the previous lesson when you were working with just multiplying and adding integers. Work on exercise 3.5. Take care, everyone.